Awesome, thank you. Yeah, so welcome to this session about hacking modern web apps with remote code execution and prototype pollution. So we're going to do first a quick course introduction because this webinar is part of our web course. So I'll just give you a 5-minute overview of how that looks like, and then we will jump into these topics, right? So this webinar is also a workshop. So I will be giving you I have already sent you an access to all to the training portal. So if somebody is watching this on YouTube, you just email admin@70security.com, and we can give you access to this as well. So when I do the demos from the training portal, you just click on the vulnerable application that where we will do the exercise. And then to just, as you're logged into the training portal, just click from the slides, and then you will be able to download those applications and then try on your own everything that I'm going to explain today. So it's also a workshop, right? So today, because we only have around 1 hour, I will just jump into the demos myself, but you can then try these exercises on your own since you have access to all these vulnerable applications to practice on your own. So I'll do a brief course introduction, and then we will talk about remote code execution options against Node.js applications. So in the case where you have some code execution vulnerability, what can you do with it in Node.js? And then we will talk about prototype pollution, and we will also talk about a cross-site request forgery case study in a vulnerable application. And all this is they're all like snippets from parts of the course, right? So these are some of the things that we cover. So I think this was more or less said in the introduction, so no point in talking too much about it, but I'm the CEO of 70 Security. If you like this presentation, on the website, you can also see a lot of public Pentest reports. So if you go to publications, there's a lot of public Pentest reports, so you can read all of those for free. And that's a very good way to learn about security, to read what has been found in other applications. Upcoming training and training options, you can check the training link. I also wrote a course for eLearn Security a while back. We have delivered training at Black Hat USA, Hacking the Boss, OWASP Global AppSec, Nullcon, and many others. Other presentations you can see here, and some certifications. If we meet someday, I can explain to you how this happened. And yeah, some public Pentest reports here. This got a bit of media attention because Smart Sheriff was an application that was mandated in the entire country of South Korea. So children and parents were forced by law to install this application so that the parent would be able to do parenting of the child, right? To control like during what times the child would be able to use the phone, what websites the child should be able to access during what hours, and what applications should the child have access to, right? So all these things were controlled by the application. So in theory, a nice idea to keep children safe on the internet. In practice, the implementation was really bad. So in these two Pentest reports, you can see everything you should never do in an application. So you can see that in this report. So it was so bad that we even gave a presentation about it. So you can watch it for free as well on YouTube, and the slides are here. And these, if you search in YouTube Chinese police and cloud pets, you will see another presentation that I gave, and that covers some IoT devices that were like pets for children to talk to the parents, and then some applications that the Chinese government uses to collect information specifically on people like Muslims in a region called Xinjiang in China, right? So we were basically trying to help human rights activists to answer the question: is this information that the Chinese government is gathering, is it a human right violation or not, right? So that was up for the human rights activists to decide, and we just helped them on the technical side. So you can read about that in these on the website. You can see these reports as well as a link to the YouTube presentation as well, and many other reports on the website, right? So just click those. Now, this particular course has been also written by Anirudh Anand. So he's a security researcher. He likes to play CTF, so he's a member of the #1 ranked team in India, Team BIOS, for CTFs. He has found vulnerabilities in Google, Microsoft, LinkedIn, GitLab, and others. Contributor to some open source projects like OWTF, Hackademic, and others. Some certifications. This is his blog and his Twitter. And then for the course itself, you basically need some basics, right? So you need to be able to connect to wireless and wired networks, ability to read PDF files. Now, a lot of people sometimes come with corporate laptops, and they basically cannot do anything, and that is, of course, not good, because you need to at least be able to import a VM that we will share, and so on, right? So that is for the course itself. So, you need to be able at least to import a VM, right? 8 gigabytes of RAM should be enough. And if you have 16 or more, that's even better. 60 gigabytes of free disk space will be excellent to be able to import a VM and other stuff that we will share. And then in this particular course, the VM that we will share is for VirtualBox, but if you use VMware, that is also known to work. And for man-in-the-middle stuff, we will be using Burp. For the course, the first 4 points are kind of normal, right? So digital copies of all training material, lab VMs, test apps, and source code for the test application. So this is kind of normal. And then something that we do that is a little less usual is that we give you lifetime access to the training portal, including all future updates for free, right? So a lot of companies will charge you whenever the course is updated, and if you want the update, you have to pay again. So we give you all updates for free, and then you get also step-by-step video recordings, the slides, and the lab PDFs, and you also get unlimited email support, right? Because nobody has enough time to finish all the labs during the class, so you can then keep trying them on your own and ask us if you have any questions. So in the course itself, the first part starts with hacking modern web apps, mastering the future of attack vector. So we do a brief setup check and an introduction to Node.js. So we talk about the Node.js app structure, vulnerabilities and dependencies. We will do a bit of this today. Vulnerabilities in source code, right? How to do some static code analysis using Node.js scans to find some vulnerabilities, and then some basics about how to secure Node applications. Then in lab 2, we talk about injection attacks on Node.js, so SQL injection, NoSQL injection, exploiting some CVs. So we do a lot of case studies about real applications, some vulnerabilities that are public. So we will be installing these vulnerable applications to practice. So server-side template injection, CRUST-CMS, server-side template injection, things like this. In Lab 3, we talk about client-side attacks on Node.js. So we talk about content security policy, bypassing content security policy with JSON-P endpoints, Markdown-based XSS, Windows post message, some case studies with known CVEs, quite recent. So 2020 is a CVEs from this year. We also have some cross-site request forgery examples, and today we will do this one, the BoltCMS cross-site request forgery from XSS to remote code execution. Also, we will be doing introduction to open redirect vulnerabilities and clickjacking. Then in Lab 4, we talk about business logic flaws, so insecure direct object references, bypassing and computing CAPTCHA, privilege escalation with in Expresscard, right? So lots of case studies from real applications. Another privilege escalation by through an attack takeover, right? Then in Lab 5, attacking NPM modules. This is because when you have a web application, the web application in Node.js is typically very small. But if you take into account all the dependencies that the application uses, then there's really a lot of code that the application is using. So in this lab, we talk about a lot of vulnerabilities that you could have inherited from dependencies, right? And these are all publicly known vulnerabilities. So lots of interesting things: directory traversal, arbitrary file write, remote code execution, regular expression denial of service, an arbitrary code injection of some of the scenarios. In Lab 6, cryptography, we talk about attacking coupons, attacking JWT tokens, and express and Laravel passport authentication bypass. This day finishes with a CTF, so there's some open challenges for you, kind of to try harder, right? So these are not like spoon feeding you. They are more kind of meant to, after you complete all the other labs, you can really test all your skills on this one, on these open challenges. And then in part 2, we talk about prototype pollution attacks. So we will be talking a little bit about this today. So we will be talking about objects in JavaScript, functions, classes, constructors, prototypes, and all this. And then in prototype pollution, how this works. So I will be talking about this today. So object recursive merge, and then how why was merge vulnerable, as well as some case studies, right? So exploiting prototype pollution in Express file upload. So this was an actual issue also from 2020. And then in Lab 2, we talk about tactile vulnerability classes, right? So this is the second day of the web training. And you can see here that some comparisons here. We have like some special cases where sometimes when a developer is making a comparison, there can be some edge cases where the comparison doesn't actually work the way the developer thought. So this could result in some problem, right? So there's a lot of things that we talk about here: type juggling in PHP, and then in Python with unpickle, and then there's also Node serialize with unserialization and getting remote code execution in Node.js through Node serialized, right? So lots of scenarios like this, and then in Lab 3, OAuth applications. So we talk about some vulnerabilities related to OAuth, right? So this is a very important topic because a lot of applications now tell you to log in with Google, log in with Facebook, and if the implementation of these OAuth is not correct, there can be a lot of issues. So we walk you through all those on that. Then Lab 4, file upload vulnerability. So again, lots of case studies here, uploading SVG images, case studies for real apps, and so on, about file uploads. And then in Lab 5, attacking file parsers, server-side request forgery. Again, many case studies: arbitrary file read by attachments, lots of interesting things. And then there's also another CTF to test your skills, right? So that's what the course is about. And now we're going to start with the actual webinar content about remote code execution options against Node.js applications. Right, so to do this exercise that I'm going to, because as I said, this is a workshop as well. So you log into the training portal, and then you click on the slides So there's a button called download slides or something like this. So just click on this, and then when you open the slides and you are on this slide, as you are logged into the training portal, just click on this, and then you will be able to download this vulnerable application. And then locally on your computer, you can try to exploit these things that I'm going to explain, right? So this is just for you to practice and gain hacking experience while you try to replicate what I'm going to show you now, right? So with that out of the way, does anybody know what the vulnerability is here? Let me open the chat. Are we required to install Burp for today's lab? It would be good, but you don't need Burp for several of the demos. So it's not mandatory, and definitely not during the webinar itself. So does anybody see the vulnerability here? The vulnerability is not port forwarding. Any other guesses? REST send function. Well, that is where the vulnerability is, but what is the vulnerability? Reverse shell. We can get a reverse shell with it, but that is not what the vulnerability is. Code injection, yes. So yeah, it's basically a code injection, right? We have an eval here on the affected code. So this is basically doing an eval of a request parameter. So you can see that this results in code execution, right? So we have a very small Node.js application which is vulnerable to code injection. This is basically doing an eval of a parameter, right? So very simple vulnerability. But then the question is, okay, if we have code execution in a Node.js application, what can we really do with it, right? So we have evaluation of the Q get parameter, right? So this is request query and then .q. So Q is the name of the parameter that this is going to be evaluating. And then this will be returned in the HTTP response, right? So REST send is basically sending the response for this GET request. And then in the response, we will see the results of the eval operation, right? So with this, we can try a number of things, right? So first, we need to do npm install express. So this will install the Express server so that we can run the application, and then you just do node and then RCE.js, and then this will run the server on port 8080. So we can then try a number of things, right? So using curl, for example, we can try to multiply 2 by 3, and then we get 6. So this is already enticing, right? Like it seems we have some sort of execution on the server side because we get the result of the multiplication. So this is getting executed. Another thing we can try is to load different Node.js modules, right? So for example, we can require the util module and then format a string with the content hacked, right? So if another thing that we can do is using PHP like this, so we can do php-r and then echo URL encode of this, and then this will return the URL encoded payload, which will be a little bit easier for us to play with. The URL encoded version looks like this. So you can also click on this from the slides. And then we will get the result of hello hacked, which means instead of any error message. So this means that we were successful to load this require util module, right? So we successfully imported this library. So we can import other modules, right? So we can require the file system module and then try to read local files, for example. So we do require fs for file system and then .read file sync. So reading a file synchronously, and then we are reading the contents of the etc password file, right? So now again, using curl, we can URL encode this payload like this. So this will result in a URL that looks like this. This is already URL encoded. And here we can see hello, and then the output of eval is going to be the contents of the Etsy password, right? So we can read local files. So these are the contents of the Etsy password. What other things we can do? We can, for example, create local files, right? So we can do require child process and then exec touch and then create a local file on TMP like hack.txt. So we can do that with curl, for example, like with the URL encode trick that I showed before. So require child process exec of touch and temp and hack.txt. So this will create this temporary file. And this is the URL encoded version. So now if you check the contents of your /tmp directory, you will see hack.txt being saved in there. So with this, we can also get a reverse shell, right? So we can, for example, for this part, we will need to have a netcat listener in one of the terminals. So we do netcat and then NLVP. So N is to avoid the DNS resolution, V for verbose, L for listen, and P to listen on a TCP port. So we're going to listen on port 4444. And then the payload that we're going to use in this case is require child process and then exec, and then we are going to create a temporary what's the name? A temporary stack file on /temp. And then this will be used to redirect input and output. So we get an interactive shell where we can see what we type, but also what comes back from the server. And we can do this without any special tools being installed on the server, right? So this can be done with the normal netcat included in web servers, which is more limited, right? This doesn't have the -e option, right? This is a netcat that is more limited, but still, we can still pull this off like this. And this is also redirecting the output, the error output into the standard output so that we see error messages as well in the terminal, right? So if we send this payload, right, again, using curl, we can do curl, and then here we do php-r, and then echo URL encode of this payload, and then we will get hello object object. But then on the terminal where we have the netcat listener, we should be able to get a reverse shell. And here we can run commands like id, ls, cat etsy password, and so on, right? So let me do a demo about this. Let me share the VM here. So first I need to start the server, right? So you do node and then RCE.js. Before I forget, I will also set up the netcat listener. And now I'm going to try first with the payloads using curl, right? So I'm using curl and then doing the multiplication here. You can see I'm getting the alert 6, right? So maybe I can make this a little bit bigger so you can see it better. So you see 2 by 3 is, and I'm getting 6. And then if I try one of the other payloads, for example, the hacked one, right? So you can see I'm doing this php-r echo URL encode of the payload. So this makes the payload a little bit easier to read while we can still play on the command line. And here you can see you get hello hacked because we are able to successfully load this module. So we can now try to do the hacked one. So this is doing executing hacked, and then I'm slipping 2 seconds, and then I'm listing the contents of hacked, and this is the current time where I am. So you can see, so if I run date, you can see this is the current time. So you can see a new file has been created on /tmp and is hack.txt, right? So this means we can run arbitrary commands and we can also create files on the system, right? So now the other one that we can try is reading Etsy password. Let's see. Okay, so this is the reading etc password, right? So here we are doing require fs and then read file sync of etc password. So if I hit enter on this, we can see here that we get this hello, and then these are the contents of my etc password file. And now we can try the reverse shell, right? So the reverse shell is this one. So if I try this, you can see hello object, but here we have a reverse shell, right? So now I can do cat etc password and run like any command I want, right? So I received a reverse shell from the server, right? So now I will kill this and I will start it again. And now we can try all this also from a website, right? So I'm going to try this from Firefox. So you can see 2 by 3 and I'm getting 6. If I do require util of hacked, you can see I'm getting hello hacked. And then if I do the require fs and read file thing, I can see the contents of etc password. And this is the one for creating the hacked file, right? So this we will have to go back to the terminal to see here if hacked. You can see, well, now it's just 28, but you can see that this has increased to the time where I ran that command to 27 past 1. And now we will do, which was the other one, the reverse shell, right? So let me check if we still have our netcat listening. Now we have netcat listening. So if I click on this and I go here, you can see I also get this cat password, name das A, free memory, right? So I can run like pretty much any command I want. So with this, you can pretty much see what is the impact of having a code execution vulnerability in a Node application, right? We can load modules, we can run arbitrary commands, and that is how you would go about it to get this working, right? So with this, let's go back to the slides. And now let's talk about another case study that we have in the course, right? The BoltCMS cross-site request forgery. And this is very interesting because it turns an XSS into remote code execution. So Bolt is an open source content management system written in PHP. And the vulnerability that we have is from an old version where a cross-site request forgery on file uploads in BoltCMS can be exploited by a normal user to upload an HTML file, which when accessed by an admin user will trigger an XSS, and we can then eventually get a shell upload, right? So we can upload an arbitrary PHP file, right? So before proceeding further, you are going to need to do this exercise. Again, from the training slides, right? So you access the training portal, download the slides, and then when you are on this slide, then you click this link, and this will download the BoltCMS, the vulnerable version of BoltCMS. So you can then download it and try to do this exercise, right? So for this, you will need to install like some things, right? So you need to unzip this. So if you put it on var www HTML, you also need to give it like some, open kind of permissions, right? So chmod, and then if you give it recursively 777, so basically all permissions, then things will work fine because it needs write access to the web root. So you're going to need to do some loose permissions like this. Of course, this is not something you should do in production, but for the purposes of demonstrating this is something that you will need to do. Then you cd into Bolt. and you will also need to run these commands to get the relevant packages installed, right? So you need to. Then you also need to enable .htaccess. So for that, you're going to need to go to the Apache 2 configuration and set up some changes, right? So you need to replace allow override none with allow override all, and this will allow .htaccess, which is also needed by this application. So once htaccess support is enabled, we also need to enable support for mod rewrite. So you can do that with this command. So you do sudo and then a2n mod rewrite, and then you can sudo service apache to restart. And then after all this, we can go to the BoltCMS by creating the first user, which will be the root user going to localhost Bolt public on your browser, right? So you go to this link, and then you already have set up these two users, admin and admin123, and editor123 are two users that already come with BoltCMS. So after all this setup, the application should be working. So admin is the first user, which has all the permissions, while an editor is a normal user with bare minimum permissions. So we will use the editor account to trigger a file upload leading to stored XSS when the admin visits the page. And then we will upload a shell which triggers a reverse shell, right? So now that we have successfully completed the installation of BoltCMS, let's dive into exploiting the vulnerability. So first we have cross-site request forgery on the file upload functionality, right? So if you're logging as admin with the credentials admin and admin123, and then you click on homepage in the dashboard, you can see an interesting file upload name files on the stack. So you can try to upload a file and see how the request is going to burp, right? So for this one, it's better if you have, somebody was asking before, do we have to install burp? So for this, it would be better if you use burp, but you can use the community edition of burp just for the purposes of, following the exercise. Then since the CMS is built on PHP, the first thing to check is if you can try and upload a PHP file and see if we can get a direct shell, right? So if you create a file called test.php, which contains like the PHP tag and then echo123, for example, and then you close PHP. So if you upload this, you will see that file type is not allowed, and then you get a list of allowed file types. Now, in the allowed file types, you will see some scary ones, right? So, for example, you can upload .html. So with this, this means basically that you can upload any HTML you want, which means you have persistent XSS, right? Because you can upload an HTML file that contains any XSS that you want, right? So that is what we are going to leverage here. So another thing is this error message is based on the configuration, right? So there is a backend chunk for the file type, and it does not allow the upload of PHP files directly to the server. So if you explore the code base, you can see that the following configuration file defines which files can be uploaded. So if you go to bolt app and config.yml, you will see here how this works, right? So if you scroll down a little bit, you will see that there's a wide list of allowed extensions being defined here, right? So accept file types, and this tells you like all the file types that are allowed, right? So if we add here the PHP extension using a cross-site request forgery, then we will be able to upload a backdoor, and then we get remote code execution on the server, right? So we can find that the PHP extension is not whitelisted in accept file types for file uploads on the CMS, but this would be a target, if we see how the request looks like to update this configuration file, and we add the PHP option to the accept file types, then we will be able to get remote code execution, right? So two very interesting things to note here are that HTML files are being allowed to upload by default, and the file uploads request does not contain any random tokens for protection against cross-site request forgery. So it is not possible for us to directly upload a PHP file to the server unless we change the configuration to add the PHP extension to the configuration file. So interesting admin users have an option to update the configuration files via the BoltCMS dashboard itself. So if you navigate to dashboard, configuration, and main configuration, then we can change the configuration. So if you edit this file and click on save to see how the request is being originated to the server, you will see something like this, right? So in this case, there is a cross-site request forgery token, but since we can upload HTML files and the file upload is vulnerable to cross-site request forgery, so there's no token on that one, we will still be able to steal the cross-site request forgery token through that HTML file that we will upload to then be able to modify the configuration file, right? So we can see that there's a file edit token parameter, which is also sent along with the content of file edit contents, which is the entire edited content of the config.yml file. So if you send this request to verb repeater and you remove the file edit token parameter, you will get this error message, right? So, okay, false, file config.yml could not be saved because the form wasn't valid. So the server is actually checking that this cross-site request forgery token is present, so we will need to steal it with the stored XSS in the file upload, right? So the cross-site request forgery token is properly being validated by the backend. So this means that the token acts as a sort of protection against cross-site request forgery attacks and validates the form from the correct user. But since the file upload functionality does not have cross-site request forgery protection, and since we can upload an HTML file, if we can trick the admin into visiting the uploaded page, then we can steal the cross-site request forgery token with XSS and then change the configuration file to whitelist PHP files and then upload a shell, right? So you first need to log in as admin. So you log out as admin and log in as editor, which is the user with the least privilege in BoltCMS, and then you try to upload an HTML file and capture this request in verbs, right? So you can create an HTML file that basically has script alert 1, and then you can see in verb how this looks. And from the response of the upload, we can also see what the full path to the uploaded file is. So it will be something like this: localhost, Bolt, public files, stager.html. So if you have the professional version of Burp, you can automatically generate a cross-site request forgery proof of concept. Just right-click on the request and go to engagement tools. So you right-click on the request and then go to engagement tools and generate cross-site request forgery proof of concept. And this will generate something like this. You can clean it up because there's a lot of stuff that is really not needed here, but it's a good starting point for getting a cross-site request forgery working. So you can see there's a post request to Vault, public Vault upload. And then you have the other request headers and the actual format of the payload. So, and this is the rest of the stager. And here we are also adding some functionality here to add the month and the year and so on. So this will return what is the path of the uploaded file, right? So the above exploit is a slightly edited version of the auto-generated Burp Suite cross-site request forgery proof of concept. So we can host this in a server we control and delete the already uploaded stager.html from the server. So then as an admin user, we can visit the hosted page and see if automatically uploads a file named stager.html to our server, right? So you can click on this link, so you can use that TXT to just download the proof of concept, and you can also just click on the HTML version from your browser, and this will do the cross-site request forgery for you, right? So This is the command to do. So you cd into var www.html, and then cd into Bolt public files, and then you can go to cd and then the year and the month and delete the stager.html, right? So now from a different browser, you can log into BoltCMS admin and then open a new tab and visit stager.html. So you can see that an alert one is being executed, which means the stager.html got uploaded, right? So then we can check if the same files again, and you can see that a new file named stager.html has been uploaded. So this proves that our cross-site request forgery was successful. Now we can change the cross-site request forgery to HTML file upload to remote code execution, right? So now our idea is to make an authenticated admin user upload an exploit.html file, which would contain JavaScript, which will initiate a request to change the CMS configuration and add PHP to the accepted file types, whitelisted. The whitelisted file upload extensions, right? So we need to modify the CMS configuration so that PHP files are allowed. So we need to do first fetch the file edit token, which will legitimize the request, and then we will be able to bypass the cross-site request forgery check. Now, since we upload the HTML file and the HTML file is being loaded from the same domain of where the CMS is running, then this excess HTML that we upload is able to read the cross-site request forgery token, and then we will be able to from there upload the PHP backdoor and get code execution, right? So the exploit chain will be something like this. The admin visits an attacker URL. The admin browser attempts to upload the initial HTML file, so stager.html, and then the attacker script will load the uploaded HTML using an iframe, and the uploaded stager.html script does the following, right? So it sends a request to configuration to extract the request token, to bypass cross-site request forgery protections, and sends the updated contents for the config.yml file along with the PHP as an allowed file type and the extracted request token from the previous step. And now PHP files can be uploaded. So using the same upload feature, a PHP file, shell will be uploaded, right? So we can then trigger a reverse shell using the uploaded PHP shell back to the attacker server. So now that our proof of concept is working, we can construct our stager.html, which contains JavaScript functions to read the cross-site request forgery token, update the configuration, and then upload the shell. So we can first write a function which can send a GET request to edit the config.yml file and read the cross-site request forgery token from the response, right? So this is how this looks like. So we're getting sending the request here, and then whenever the response is received, we get the response XML and we extract the cross-site request forgery token from the response XML, right? So, and then we get this obtain cross-site request forgery token. So we save this in the console log just for debugging to see that things are working. So now that we have obtained the cross-site request forgery token, we need to edit the configuration file to add PHP into the valid list of tags. So we can visit this link and then try to add PHP into the whitelisted extensions. Ensure that intercept request is on in Burp Suite, and then click on save. And then you can copy the value of file edit contents and drop the request so that PHP is not considered a whitelisted extension yet. So this is how this looks like. So we will have a function here to update config with the cross-site request forgery token. So we will be calling the function here. So we have the function to read the token, and then we update the configuration. This is the function to update the configuration. Here we would replace this with the token from Burp. And then this is being sent, right? So yeah, these are basically the steps to get this all working. and then we can specify the reverse shell IP, the reverse shell port, and so on. So we can then try to get our reverse shell with this, right? So now this is the same proof of concept. We update the configuration with a valid cross-site request forgery token. And here we replace this with the configuration file. And we upload the shell. So the upload shell is basically another file upload because we have changed the configuration so that PHP file extension uploads are allowed. So now we can upload or reverse shell, and then we can put a shell one-liner like this, right? So we can do ORM, and then basically it's the same shell one-liner as before, but with the reverse shell and the port in here, right? So now all we have to do is to try this and upload the stager, and then we can use Burp to generate a new cross-site request forgery token, which we can slightly modify to include the uploaded file as an iframe to the attacker domain, so that stager.html gets executed and we get a successful reverse shell back, right? So for this, you need to download the full exploit, and this is the final exploit with all the details to get the reverse shell back and everything else, right? So that is how that looks, but it's basically chaining all the steps. And then we can download the Vault exploit, and you can extract it to a local directory, and then you can try it from, you need to open a new terminal and ensure that you have a netcat listener. And then from the browser, you can visit the BoltExploit.html and check that the netcat terminal for the incoming connection, right? So this is the case study. I think there were some problems with the demo. So I will just do a part of the demo, right? But to show you a little bit how this is. So this is the BoltCMS. And basically, if you try to upload a PHP file, it will say that it's not allowed. So this is the dashboard. So you need to go first to the dashboard and home. I think is the, yeah, this is the files on the stack, and you can see that this is the stager, right? So with the cross-site request forgery, so I can try this cross-site request forgery, and this will add the stager, and you can see that we get an alert one, right? So if I do F12 here, and we can see the network. So I'll do it again. So you can see that this is the get request to the cross-site request forgery, and then the suppose request to upload, right? So this is the origin from where the exploit is being executed, the cross-site request forgery, and then this is doing the upload to localhost, right? Which is a different domain that's 7a.es, right? So this is the actual upload. So you can see here the request headers, the response headers. So this is the full request. So we are uploading an HTML file that contains script alert one. And this is the response. So it's basically working, right? And now we have here in files stager.html, right? So we have here the URL bold public files stager. So if I copy this, this is where the file was uploaded. So if I copy this and paste it here, I think, yes, and we get the alert one, right? So using this concept and following the other steps, we can then, since we are able to run any HTML we want on the host, we can then read the cross-site request forgery token and be able to update the configuration, allow PHP files, and then upload a PHP file to get code execution, right? Since we have a question in the chat, can we somehow perform an application level denial of service on Bolt CMS websites. Well, since you can upload arbitrary PHP files after you have code execution, you can delete everything on the server or do anything else you want. So yes, you can, after the remote code execution, you can do a denial of service as well, right? So if you follow the exercise and do the remote code execution, you will be able to turn this into a complete denial of service. You will be able to delete the entire servers, the entire server, right? Okay, so now let's move on to prototype pollution, since we are a little bit short on time. So let me try to fly through this. So prototype pollution attack, right? So here we talk about, just give you an introduction about what this is, and then to see this in practice, right? So this sometimes can lead to remote code execution, which is a very interesting scenario, right? So basically, in JavaScript, everything is an object, right? So an object is a collection of key value pairs, and each pair has a property, right? So object is the fundamental object upon which all further objects are created, right? You can also have an empty object, which can be created by passing null as an argument to object create. So if you do object create of null, then this will create an empty object. And then a normal object in JavaScript will create an object of a type that corresponds to its value by default and inherits all the properties of the newly created object unless it's null, right? So let's see some examples of this. If you do console log, so you can try this in your browser. If you do F12 and you type this, so you can do console.log and then object create null, and this will create an empty object. So you can see this is completely empty and there's no properties, right? So there's no properties because the object is empty. So this happens when you create the object with this null argument. So now the concept of functions and classes are relative in JavaScript, as functions itself serve as the constructor for the classes, and there are no explicit classes. So when a function is created, by default, the JavaScript includes a prototype property to the function, which is nothing but an object. So it's called a prototype object, and this object has a constructor property, which points back to the function on which the prototype object is a property, right? So basically, if you have a function like this, function company, this name, this founded, these details, and you do console log of company.prototype, you can see here that we have the constructor f and then constructor and then this underscore underscore proto underscore underscore. So this is basically the object, right? So the constructor points back to the function itself. If you do console log of company.prototype and company has been defined as a function, this shows the prototype of the function, right? So all the inherited properties. So if you, for example, create a company like this, so you do a new company of Google and then 1998, and then you do console log of company one and company one dot details, then this will print the details of the company, and we can see the structure of this and also the underscore underscore proto constructor and then underscore underscore proto, right? So you can see that underscore underscore proto points to the function dot prototype, right? So this is what we want to attack basically. So the constructor is a magical property which returns the function that was used to create the object, right? So we have here company 2, new company, Amazon 1994, and then here we have company name, founder, whatever, and company 2 dot constructor, and this will show the function, right? So constructor dot constructor points to the global function constructor. So the prototype object has a constructor which points to the function itself, and the constructor of the constructor points to the global function constructor, right? So basically there's this inheritance going on, right? So even though prototype objects are added by default, it can also be modified at runtime. So here we modify the function prototype to add a new property. So we can get similar results, right? So if you do company.tool.details, if you try this on your browser, again with F12, you can try all these examples by yourself and you will see this. You will get this company2.details is not a function, But then if you do company1.constructor.prototype.details equals function, the company name this.name was, and then blah, blah, blah. And then you do company2.details, then this will work, right? So you can see that a change in company1, so here we're changing the constructor prototype of company1, this affects the company2, right? So this is very interesting because changes in the prototype affect different objects in the system, right? So this can sometimes result in interesting security problems, which is what we're going to see. So basically, if you have an object and the attacker can control A and C, so the attacker can control A and C here, then the attacker can set the value of A to __ proto here, and then the property B will be defined for all existing objects of the application with the value C, right? So if the attacker controls this and this, then the attacker can redefine the method B for all objects in the system using the __ prototype here, right? So the attack is not exactly as simple because we need these three requirements. So at least one of these has to happen. So we need an objective recursive merge, we need a property definition by path, or an object clone, right? So we need one of these three things to happen. So this is the pseudocode for a merge, right? So this is basically looping, has two objects, and then it loops through the source object, and then it checks if a property exists, and then it will merge, and it will basically try to merge all the properties so the clone is complete, right? So yeah, that's what that's about. So to do this exercise, again, while you are logged in on the training portal, just click on this link. So first download the slides, and then when you get to this slide, click on this link, and you should be able to download this prototype pollution application to test and verify this. So while you're doing this, unzip the vulnerable application. So unzip prototype pollution.zip, and then you cd into proto, which is the directory that will be created after this, and then node proto.js. In case this doesn't work, you may need to do npm install express body parser, cookie parser, and path. So this will install all the dependencies for this application to work, and then try node proto.js again, and then you should be good to go, right? So this is the analysis from the source code that you can see in the application. I'll show this during the demo. And then you can also try this on the Node.js interactive command line to understand it better, right? So if you run the node command and you try this, you will also be able to see how this merge works and all this, right? So if you paste all this in the console, you will be able to see this. So you can, for example, var body JSON parse of name 70 security, and then you copy body, and then when you do copy body.name, you will see that this results in having 70 security as the name, right? So we can pass the __ proto into the JSON, and then with that we can, for example, set admin to 1, right? So then every object in JavaScript will have admin set to 1, which can sometimes help you escalate privileges to admin, right? So if you do admin, and then the first time it's going to be undefined, and then you do var body JSON parse of all this with admin set to 1, and then you do var body of the clone. So this does the copy of the __ proto, and then you do admin, and then this results in 1, right? So basically the admin object got polluted by this JSON parse operation due to the clone object here, right? So this was one of the requirements for the attack to work, right? So with this, we can take this in the flow. So you can take this in the source code. So I'm just going to jump to the demo to demonstrate, but basically, if you pass the prototype in the JSON request that goes to the server, we can then modify the prototype for all objects loaded in JavaScript, as long as there is some clone operation going on, right? So Yeah, this goes into a little bit more detail about this, but that is basically how it works. So with this, we can try this in the vulnerable application, right? So we can do content type application JSON, and then in the body we can send a name 7asec on sign up, and then we try to get the flag, and you can see that you are not authorized, and admin is undefined. And then if we do it again, but we set admin to 1, and then we try to get the flag, then you can see you have successfully polluted the object, right? So let's do the demo, and then this will make more sense. So if I go here, and I go back to the terminal, so this is the prototype pollution, and I'm going to run the server. And here we can try these things, right? So in this case, first I'm just sending a request of name and 7asec, right? So there's no prototype pollution here, and then we are making another curl request to the flag, so we can see that the cookie is set, but we are not authorized because we have not polluted the admin object, right? But if I do move my face a little bit down, if I do this, right, let me make this a little bit bigger. So if I do 7asec and then underscore port of admin 1, now we are polluting the object, right? So you can see the cookie set, and then we have successfully polluted the object, right? So how is this working, right? So we need to go to Node.js to understand what's going on, right? So I go to Node.js, and let me see here. So you can see here that before admin was undefined, so this is why it didn't work. And then the second time when we provided the prototype, admin was set to 1. So if we go here to the proto.js, we can see that this is the merge operation where the two objects have been merged. And this is doing the JSON parts of the request, and it's saving it to the body. Now here we have the clone operation, so this is where the problem occurs, because during the clone operation, then this is polluting the prototype of the object. So this is doing the prototype pollution on all objects in JavaScript. So even though we are working with copy body, we will be polluting the admin object, right? So this is saying that the cookie is set, but then when you get the flag, this is basically checking if admin.admin is set to 1. So because admin is an object, this is doing a JSON parse of the JSON stringify of the cookies. And then this is checking admin is 1. So this here we were doing the console log, so you could see that this was undefined. So this was undefined first, right? And this is why it was not authorized, and then it was set to 1 later, right? So when it was undefined, we were here, you are not authorized, because we had not polluted this admin, and when we polluted the admin, we were here, so you have successfully polluted the object, right? So this is why it worked. So let's go back to the slides to wrap this up. So yeah, there's other prototype pollution scenarios in the course. So with this, if there's any questions, I would also like to mention that there's a special offer on the store at the moment. So if you are interested in any self-paced course, there's a 25% discount. So if you go to the store, the discount is listed in a banner there. So if somebody is interested, you can check that out. But otherwise, this is the end of the webinar. So are there any questions? Does anybody have any questions? I'm checking the chat now. Yeah, if you can type your questions, no questions. Cool. So all these exercises you can try on your own, right? So from the training portal, you can download these applications and try them out on your own. If you have any problems, you can email at admin@7asecurity.com and we will help you out if you run into some problems or you have any questions. Awesome. Yeah. There was a question in the question and answer section. Sir, if we have to contact you personally, where can we contact you? Just email admin@7asecurity.com. And then, cool. Yeah. So, and then the other question was thank you. So, okay. So all questions answered. Awesome. Well, thank you, everybody. And if there's no more questions, then we will stop the webinar now. Thank you, everybody. And just if you feel free to ask any questions at admin@7asecurity.com, and we will be happy to answer any questions you may have. Have a nice rest of your day. Thank you for coming, everybody. Bye.